Hi, this is Tariq Rashid. Welcome back to our class of Advanced Artificial Neural Network. This class is related to Convolutional Neural Network, CNN. This is part one, a theoretical part, and there's also a practical part in part two. So CNN is a deep learning neural network type designed to process structured grid data or data, especially images. It's a medication for image processing or images. If your data is about images, then CNN is a great medication for it. Now, CNN automatically learns visual features from images such as edges, textures, shapes, and objects. Unlike multi-layer perceptron machine learning, CNN do not require manual feature extraction. CNN learns features automatically during training through forward pass and backward pass of backpropagation algorithm. CNN are widely implemented in image classification, object detection, facial recognition, medical image, autonomous driving, and video analysis. Historical background, the roots of convolutional neural network go back to neuroscience or visual cortex studies. Key achievements here in 1980s, and 1990s, Jan Lucan developed early CNN models. Jan is a French American, first person who worked with developing CNN models. In 1998, AlexNet 5 for handwritten digital recognition used by banks. And then in 2012, Alex, Ella, and Jeffrey Hinton coined AlexNet, which won the ImageNet large-scale visual recognition challenge and sparked the deep learning revolution. Phases of CNN, it has several phases. The first one is input layer. Second one is convolution layer and activation layer, pooling layer, next flatten layer, and after fully connected layer, and finally output layer. So this input layer, that's max pooling and convolutional, max pooling, convolutional, max pooling, convolutional, and so on and so forth until the final, which is called fully connected layer. CNN, we said that the first layer is an input layer. Input layer receives raw image pixels, for example, 64 by 64 by 3, 64 the height of the image, the other 64 is the width of the image, and 3 represents color channel, RGB. The purpose of this layer is to feed the raw image data into the network CNN. Second layer, convolutional neural network, or convolutional layer, sorry. This layer applies filters, sometimes called kernels, that slides across the image to detect patterns. An example of these filters could be 3 by 3, and then it slides across the image. image patch multiplied by filter, then you will get feature value. Early layers detect edges, corners, simple textures. Deep layers detect shapes, objects, and to extract meaningful visual features from the image. This is the core of idea of CNN. So CNN actually automatically does feature extraction. Okay. Now, activation function, we call it ReLU, rectified linear unit. If it is negative, it'll scale down to 0. And if it's positive, that is max. We take the max of 0 to x. Example, -2, 3, -1, 5. Output 0, 3, 0, 5. 2 become 2, -2 become 0. 3 is 3, max, we take it. And -1 is 3. 5, it remains 5. So mainly this function introduces nonlinearity and removes negative values, as we said that here any negative values will be considered as 0, and supports the network learn complex patterns. Without activation function, the network would behave kind of linear model. Polling layer, this is kind of reduces the spatial size of feature maps. Max polling, it means that if you have input 4, 3, 6, 5, you'll take the max of them. So you wouldn't take those 4 values. So when you take the max, it means that that's 6, we take 6 there. So that is the reducing the complexity of computation. Again, we said that reducing computation, reduce memory usage, reduce overfitting, and keeps the strongest features. It also makes CNN very dynamic to small shifts in images. Flatten layer converts 2D, two-dimensional feature maps into one-dimensional vector. So if you have, for example, 6, 2, 7, 8, then you will have as a vector flatten 6, 2, 7, 8. So convert two-dimension, that's two-dimension, that's two-dimension into one-dimension, one array vector. And neural network classification layers requires vectors, not matrices. Flatten prepares the data for the fully connected layer. Fully connected layer, this is the kind of the a dense neural network layer where neurons connect to all neurons. Neuron output, sigma of input multiplied by its weight, W1 times X1, W2 times X2, W3 times X3, and so on and so forth, plus the bias. And by the way, bias will prevent the output to be 0. For example, if you have all your inputs 0, you multiply 0 by the weight, it will be 0. So bias, usually the value of 1 will be added to the sum of the input so that we prevent the output to become 0. And there's also one more advantages of bias is that it allows activation function to shift. Okay. Now, output layer, this is the softmax, converts the final output into probabilities, for example, then the voting can be done. Cat 0.82, dog 0.18, so cat will be considered. The class is cat. So this is softmax, usually to helps you uh, to make a decision based on the probabilities that you receive at each neuron in the output layer. So final workflow of CNN, you've got image, feature extraction using convolutional layers, and then nonlinear transformation, and then pooling or reducing size, pooling layer, and then flatten, convert to vector, and fully connected decision making, and then softmax class probability. We said that hierarchical representation of CNN, you've got edges, then textures, then shapes, then object. This is the diagram that we explained earlier. This is another diagram another simple diagram to represent your CNN. Advantages of CNN. This is different from traditional neural network. This does feature extraction by itself. You don't need any other tools or approaches or methods to do feature extraction for it. Smaller filter is used across the image. Then you will have fewer parameters. Detects objects regardless of position, and it does image classification, object detection, and medical images. Usually works well with large data sets and GPUs. The limitations or disadvantages of CNN, it needs large data and needs a lot of labeled data for good performance. Computational wise, very expensive. You need GPUs and TPUs, which is special type of GPUs. TPUs, TensorFlow processing units, GPUs, graphic processing units. It's very difficult to explain it. It's a black box, and it is sensitive to transformations. Okay. And it has a risk of getting overfitting problem. Because usually when you have small data, you will have overfitting problem. Where can we use CNN? We can use them for images, any application that is related to images, or images are relevant in those applications. So CNN can be used to solve those applications. Medical imaging, autonomous driving, speech recognition, and natural language processing in some cases. So just in simple intuition, CNN, it has first layer, find edges, middle layer, in the middle of between first and output layers. They are responsible for finding shapes, and the final layers recognize objects. Thank you very much for this class. Next class, it will be a practical part of CNN.